In this video, we're going to go through a couple of probability questions similar to the ones you may see on the ACT. Let's take a look at question number 1. In a bag of 200 marbles, 20% are green. If you randomly pick a marble from the bag, what is the probability that the marble you pick is not one of the green marbles? So not is one of our special keywords we want to pay attention to. And there's a couple of different ways you can approach a question such as this. So first of all, I want to call your attention to our answer choices. They are all in fractional form. In our question, we used a percent, so we need to make sure that we're comfortable with percents and fractions. Our question is asking if we know that 20% of the marbles are green. We want to know if when we draw a marble, when we pick one, what's the probability that it's not green? So if 20% are green, then 80%, 100% minus 20%, are not green. So we have an 80% chance of not green. Now, here's the difference. We don't have percents like we said. We have fractions. So we need to make sure we can go from 80%, which is the same as 80 over 100. We could reduce that down to 8 over 10, still reduce that down to 4 over 5. That's how we can go by hand from a percent to a fraction. So our answer is 4/5, answer choice E. Make a note that we did not even use this 200 in any of our calculations. It is extra information. The question could have been worded a different way when you would have needed it, but we didn't even need that here. So be aware of that. We want to read our question, figure out what the question is, and use the data that is pertinent to the question. Question 2 says a bag contains 8 identically sized solid colored chips. There's no distinguishing factor there when we're going to be drawing things from the chips. 2 chips are blue, 3 are red, and 3 are green. So they are different colors, but if we're drawing that from a bag, we're not going to notice that. Okay, a chip is drawn at random and returned to the bag. That's important information, that it is returned to the bag. We'll see how that plays a part. Then a second chip is drawn at random. What is the probability that the first chip is green and the second is blue? So we're looking for the probability that the first one is green and the probability that the second one is blue. So let's look at each one of these probabilities. The probability that the first one we draw is green. Well, if you remember our definition of probability being a part over a whole, we want to look at first how many green do we have? We have 3 green over a total of how many chips? 8 chips. And we get that from 2 plus 3 plus 3, and they told us 8. So the probability of picking the green on the first draw is 3 over 8. Now we have a probability that the second chip is blue, but remember, we returned the green one to the bag. So first of all, let's look. There are how many blue chips? There are 2 blue. And how many chips total in the bag? There are 8, because we returned the one green that we had pulled out. So now we want to know the probability that both of these occur. 3/8 and 2/8 occur. We're going to multiply these together to get that probability. And when we do that, we could do that by hand or on our calculator. We get 6 over 64, and we can reduce that down to 3 over 32 because our answer is in fractional form, and that is answer choice F, 3 over 32. Question number 3 says, suppose that A will be randomly selected from the set -4, -2, -1, 0, 3, and that B will be randomly selected from the set -1, 0, 1, 2. What is the probability that AB is less than 0. That's what we're looking for, this probability. So again, probability, we're thinking a part over a total. So the first thing that we need to look at is when we look at AB, we need to see where is it less than 0. That's going to be part of our numerator. We have a numerator and a denominator. And the denominator is the entire sample set of A times B. So first of all, we look at our two different sets. We have the set A, which is composed of -4, -2, -1, 0, and 3. And then we have set B, which is composed of -1, 0, 1, and 2. So figuring out AB less than 0, we have to look at multiplying each one of these A's with each one of the B items. And we have to do that. We have to look at where it's less than 0, and what that indicates to us is that the product of A times B is a negative. So when we multiply -4 times -1, we're going to get a positive. -4 times 0 is going to give us a 0. But when we multiply -4 by both a 1 and a 2, we get a negative. So we have two negatives there. So we have to do that for each one of these items. So if we multiply -2 by -1, we get a positive. -2 times 0 gives us a 0, but -2 times 1 and 2 is going to give us each a negative. So we'll have two more. Same thing for -1. Multiplying by -1 and 0 is not going to fall in that case, but by 1 and 2, so that's two more negatives. Now we'll look at 0. When we multiply 0 by any one of these, we're only going to get 0. So that's not going to be one of the options that's less than 0. Looking at 3, the only one that's going to give us a negative is when we multiply it by -1. So that just gives us one more. So for our numerator, we have 2 plus 2 plus 2 plus 1. And that's going to end up giving us a 7 in the numerator. Those are the negative options. Now for A times B, how many different options did we have for that? When we multiply 1, 2, 3, 4, 5, we have 5 choices for A and we have 4 choices for B. So like we have done before in some of our other sections, determining how many possibilities we have 5 ways of doing A and 4 ways for B. We're going to get the total number of that, of our sample set, by multiplying these two, which gives us 20. And you could have done that. We did that when we actually looked at -4. We had times each one of these, -2 times each one of these, -1, and on and on. That gives us a sample set total of 20. So for our probability that we're looking for how many negatives we have over the total, that is 7 over 20, which is answer choice C. Number 4 says there are 14 red jelly beans, 10 green jelly beans, and 8 pink jelly beans in a bowl. How many additional pink jelly beans must be added to the bowl so that the probability of randomly drawing a pink jelly bean is 2 over 5? So we want our probability to be 2 over 5. And by definition, when we're looking at probabilities, it's the part over the whole. We know right now we have 8 pink jelly beans over a total of 14 plus 10 plus 8. Right now we have 32 jelly beans in the bowl, 8 over 32. But we want the probability to be 2 over 5. So we're asking how many should be added. So we're going to add some number X, and if we add them to the pink list, that's going to make our grand total go up. So we'll add it to the denominator as well. And we've got this set up now as a proportion. We want this number that we've added to equal 2 over 5. So we can solve this though like we do a proportion where we cross multiply. That's one way we can do this. So we would have 2 times 32 plus X equal to 5 times 8 plus X. And we want to solve for this unknown variable X. So we get 64 plus 2x is equal to 40 plus 5x. And let's pull all this over here. We're going to combine like terms and get our x's together. So I'm going to subtract 2x from both sides, and we'll get 3x on the right hand side, and subtract 40 from both sides and get 24. Divide through by 3, and we'll get that x is equal to 8. So that means we need to add 8 pink jelly beans to both of these so we can get 2 over 5, and that is answer choice J. Question 5 and 6 is going to make use of this chart. It says the local city government proposed an increase to the city sales tax. A survey asking opinions of the increase are summarized in the table below. We have the table here. Suppose a person was chosen at random from those surveyed. Which of the following values is closest to the probability that the person chosen is a non-resident and will not have replied with a no opinion? So if it means they will not have replied with a no opinion, the two options that we're looking at is that they would have given an approve or a disapprove. That's what we're looking for in our non-residents. So it did not give us the total of how many were surveyed in this, but we can get this from this bottom line here. If we add 69 plus 55 plus 18, we had 142 total. And we get that from adding across. You could have actually added across each one of these and then sum that up, but we'll use that. That's going to be our denominator in our fraction, but we look at our answer choices. They are in decimal form, and we can do that. We can use our calculator. Now we have to think about the numerator, and the numerator is what is represented by this non-residence that did not say no opinion. So a non-residence of approve and disapprove. So we go to our non-resident line, and we're looking at the approvals and the disapprovals. So that's 26 plus 23, which gives us 49 over 142. We can put that into our calculator, and we get approximately 0.345, which rounds up to 0.35, and that is answer choice C. Question 6 says it was discovered after the table was constructed that 12 non-resident responses had been incorrectly classified as approved. After correcting the errors, exactly 30% of the non-residents had no opinion. To the nearest 1%, what percent of total respondents disapproved this proposal? So this is going to be like a multi-step question. We have to do a couple of things. We want to make sure we get the data correct, and that's what they describe in the first couple of sentences. So what they say is 12 non-resident responses had been incorrectly classified as approved. So we have to take these 12 non-resident responses and subtract those from what we originally had. 26 minus 12, that's going to give us now 14 approvals. To do our calculation, we know that we have exactly 30% of non-residents that have no opinion. This is after the correction. So I'm going to take that 30%, change it to a decimal, and I have to figure out how many total non-residents we have. And we can get that from adding up. We could take our original number because it doesn't matter yet. 26 plus 23 plus 11. We still have this same number of 60 that is distributed among approve, disapprove, and no opinion. We're just going to have a change in how those votes have come out. So we still have 60. We'll use 60 in our denominator for non-residents, but we don't know how many no opinions we have. And to solve for this x unknown, we'll take 60 times 0.3, which is going to give us 18. So we now have, for no opinion, instead of 11, we have 18. So to get to the 18, we took the 11 and we took 12 of those that responded that were incorrectly listed. We'll take 7 of those to get to the 18. That means we'll take 5 and move those to the disapprove. So now the disapproved list is now at 28. Now, why we have to do all of that is because our overall question is asking what percent of total respondents. Now again, our total respondents, this has not changed, is still 142. How many of our total respondents responded they disapproved this proposal? So now our new disapproval number, we have 32 plus 28, added 5 to that. So we should have a number of now 60 total disapprovals. So we'll use that as our numerator, and we'll plug that into our calculator, 60 divided by 142, and it says round to the nearest 1%. I get 0.422, so that's approximately, that's going to go to 42%, which is answer choice H.